Okay, and we'll be looking at one type of disk, and that is the magnetic disk. There are many types of disks, but we'll be looking at the most common ones. Okay, now if you're going to see, as far as the disk input output devices is concerned, they come in many variety, and the most common one are magnetic disks, and these are a very own hard disk and floppy disk, which has somewhat become totally obsolete. And then you have USB drives also, okay, which where their function and functionality are characterized by the fact that they do a lot of read and write, which are very fast, okay, which makes them ideal as secondary memory. Then you also have array of these disks, okay, which are used to provide high reliable storage, especially for volumes of data that are being transferred to and fro. For example, as seen in a social media website, or online shopping website, or for that matter any other ERP softwares that are used by an organization. For this, you have to use another type of disks, okay, which are nothing but an array of these disks, okay, which we call them as RAID, R-A-I-D, okay, which we refer to them as R-A-D. So this is another category of this. And then you have the various kinds of optical disks that we have seen, though they have somewhat become obsolete in a sense, though they are still available, like CD-ROMs, CD recordables, and DVDs that are used for distribution of programs, data, and movies. Now we'll be looking at one type of disk, and in terms of the hardware arrangement of such disks, and that is the magnetic disk, or we call them as hard disk or floppy disk. Okay. Now as far as these devices are concerned, they are being organized into cylinders, okay, where each one contain as many tracks as there are heads stacked vertically on top of each other. Now these tracks are divided into sectors, with the number of sectors around the circumference, which will be having around 8 to 32 on a floppy disk and up to several hundred on a hard disk. Okay, and the number of read-write heads vary from 1 to about 16. Now some of these disks also have little electronics, okay, that are used to deliver simple serial bit streams, okay, and on some of these disks the controller does most of the work, and then on other disks, especially in IDE disks, okay, the disk itself will contain a microcontroller that does this work of reading and writing and allow the real controller to issue those set of higher level commands. Okay. Now a device feature that has important implication for the disk driver is the possibility of a controller doing seeks on 2 or more drives at the same time, okay, especially when the hard disk is being divided into 2 or more logical drives. Now for this, it will perform what we call overlap seeks, where here, okay, while the controller and software are waiting for a seek to complete on one drive, the controller can initiate a seek or another drive, okay, and many controllers can also read or write on one drive while seeking on one or more drivers, which is possible in most of the hard disks that you see nowadays. Now as far as floppy disk is concerned, its disk controller does not allow reading or writing on 2 drives at the same time. Okay. Now when you're going to look at the specification of most of the modern hard disks nowadays, you need to consider the geometry specified, okay, and used by the driver software, which may be different from the physical format. Now on older hard disks, okay, the number of sectors per track is always the same as the total number of cylinders, okay, for all the cylinders, okay, but most of the modern disks nowadays are divided into zones with more sectors and outer zones than inner zone. That means that you'll have less sectors inside the inner zone and more out in the outer zone. For example, a tiny disk with 2 zones will have around 32 sectors per track in the outer zone and only 16 sectors per track in the inner zone. Now to hide the details of how many sectors each track has, most of the modern hard disks have a virtual geometry that is represented by the operating system. Okay, when the software is instructed to act as though that there are X cylinders, Y heads, and Z sectors per track. Okay, so the controller will then do a remapping of a request for X, Y, Z into the real cylinder head and sector. For example, for Pentium-based computers, the maximum value for these 3 parameters are often referred as 65,535 cylinders, okay, and each of these cylinders there is 13 rewrite heads, for which each of these sectors, each of these track, okay, there will be around 63 sectors. Now on this machine, if you have a bit field like this 6 4 and 6 bit fields, these are used to specify, okay, the numbers indicating cylinders and sectors numbered at 1 and head number starting at 0. Now with these parameters, and let us say per sector there are around 512 bytes that can be stored, the largest possible disk is around 31.5 GB. Now to get around this limit, many disks now support a system called logical block addressing, in which each disk sectors are just numbered consecutively starting at 0 without regard to the disk geometry. Okay, and this is an example of the disk parameter for the original IBM PC floppy disk and a Western Digital WD 18300 hard disk model. Okay, so if you're going to see in IBM 360 KB floppy disk, there are around 40 cylinders, but for a WD 18300 hard disk there are 10,601 cylinders, and per cylinder the tracks are 2 in this floppy disk and 12 here, and sectors per track is 9 here and 281 on an average, and sectors per disk is 720, and here it is around this figure. Bytes per sector will be around 512. So the disk capacity for this floppy disk will be around 360 KB, and for this one is 18.3 GB. Now the seek time for adjacent cylinders is 6 millisecond for floppy disk and 0.8 millisecond, which is very fast seek time. Average case 77 millisecond, this is 6.9. Rotation time, this will take more time than this one, and motor stop and start time, it takes this much, and for this much. And time to transfer per sector is 22 millisecond, and this is microsecond. So this is much more faster. Okay, and this is the physical geometry for this with 2 zones. Okay, so you can see here there are lesser zones and this is more zones. Okay, and this is a possible virtual geometry for most of the disks. Okay, now the other hardware management of how other types of hard disks are concerned, okay, that part I'll leave it to you, how this hardware management of CD-ROM looks like. Okay, and with regards to DVD-ROM also, I'll leave it to you to go through. Okay, so this is about that, and in the next class I'll be talking about one important activity that occurs with a hard disk or any disk types in a computer system, and this disk formatting. So what is this formatting, how does it work, and how important it is? We'll talk about it in the later class. Thank you.